The current learning target is solving radical equations and potentially inequalities. Examples of radicals are square root equations or inequalities, what you're seeing here, or potentially cube roots, which is overall solve the same, but the difference is you have to cancel out a cube root with a cube. So a root with a 3 in it raised to the third power. There's other videos that are covering this. This particular video, we're solving the square root of x plus 5, close the square root, minus 2 less than or equal to the square root of x minus 3. Some prior knowledge we need to understand. A square cancels out a square root. So if I have something like x plus a and a square root and I square it, the square root's going to go bye-bye. It's going to disappear. And if I square the square root of b, once again, the square root's going to go bye-bye. So ultimately, to get x by itself, we apply all our reverse order of operations. But we need to understand squares cancel out square roots. Before we do that, a great example of that is the square root of 9 squared. Well, square root of 9 is 3, and 3 squared equals 9. So that's some quick justification that squaring a square root is going to cancel out the square root. Also, we got to understand the overall idea of foiling or multiplying / distributing quadratics. So if we have something u plus or minus a v squared, that's ultimately saying you're going to have something squared plus or minus 2 of the somethings multiplied plus the other thing squared. All right. So applying that to this problem, the first thing that we need to understand, to cancel out the square root on the right side of the inequality, we need to square things. If I square one side, I need to square the other. And this is temporarily going to make the left side of the inequality much more complicated looking. So we would ultimately have, to best understand it, we're going to have x plus 5 minus 2 multiplied by itself, because squares or exponents of 2 tell you you're multiplying some quantity by itself twice. And on the right side, things get really simple really fast. It's just x minus 3. The square cancels out the square root. So now foiling this, all right, the root x plus 5 times x plus 5, well, that does exactly what happened on the left side. We're going to end up with x plus 5. Meanwhile, root of x plus 5 times that negative 2, here's our first, here's our outsides. We're going to have negative 2 root of x plus 5. If I do the insides here, so the negative 2 times x plus 5, I'm going to have another negative 2 root x plus 5. And I'm going to struggle to keep things lined up. I'm going to come close here. And then lastly, we need to do negative 2. And this is the lasts of both those factors. Negative 2 times negative 2 is plus 4. It's not inside the root. Once again, the x minus 3 on the left side doesn't have anything to do for a little bit. It's as simplified as it gets. So now, combining some like terms, the plus 5 and the plus 9. If I combine those and kind of simplify things here a little bit, on the left side of the inequality, we now have x plus 9. And I have the negative 2 times x plus 5 and the negative 2x plus 5. Well, negative 2 and negative 2 of something is the same as negative 4. And once again, the plus 5 and the plus 4 is where the plus 9 came from. So now on the left side of the inequality sign, excuse me, I want that to be red, is the x minus 3. All right, so if I subtract x from both sides, they're going to cancel out. The plus 9, the opposite of plus 9 is minus 9. So my next line of reasoning would be something like negative 4 root of x plus 5 is less than or equal to negative 12, because negative 3 minus 9, negative 12. 3 bad guys, 9 bad guys, altogether 12 bad guys. So finishing up the problem here, our last two big steps, all right, opposite of timesing by negative 4, because negative 4 root x plus 5, that means we're multiplying by negative 4. The opposite of that is dividing. Let's make that sign nice and neat. Dividing by negative 4. Sorry, the negative sign. There we go. 4. I'll write that nice and neat. Apologize. If you're watching this step by step and not jumping straight to the end, these steps are going to make sense. Because again, the only thing that's new is we got a square to cancel out square root. Everything else you've been doing since pre-algebra and definitely during Algebra 1 and geometry. All right, so what do we got left over after that? Well, we got root of x plus 5 needs to be less than or equal to negative 12 divided by negative 4 is positive 3. Okay, what's the opposite of squaring? Square rooting, excuse me, square. So the square cancels out the square root. We just have x plus 5 left on the left side. And 3 squared, positive 3 squared, is 9 on the right side. So from there, the opposite of plus 5 would be minus 5. And our final answer would be 4. Okay. One big thing that I completely overglanced, and here's Desmos checking things for us. I forgot when you divide by a negative, that's going to flip the inequality sign. So right through here, all those inequality signs have to flip. And again, I'm going to show you this real quickly at the end so you're solving for an inequality. You're solving things basically the same. But if I divide by a negative or multiply by a negative, that flips the sign. And if you stop and think about it, I had negative something here, negative something there. I just flipped around. I made them both opposite. If I make them opposite, I need to make the signs opposite. So my final answer is x greater than or equal to 4. So kind of scroll back up, let you see the whole thing. So again, I squared both sides. I had to FOIL. The foiling, I ultimately have negative 2. Negative 2 times itself, times 2 is negative 4. There's the whole plus or minus 2 UV. And then subtracted x from both sides, that cancels out. Subtracted 9 from both sides, that's how we got into the negative 12. Divided by negative 4, and right there, that's the key part. I divide by a negative, the sign flips. If I didn't divide by a negative, what I initially showed you is completely correct. And now double checking all of this on Desmos. Okay. On the top. All right. So when I go look back at the equation, if I cover up this part, this is saying, all right, some stuff has to be less than or equal to x minus 3. So that's the bottom equation. Those are all the things that are below root of x minus 3. Not x minus 3, but root of x minus 3. If I go back to the equation and I look at it, something has to be, if I read this from right to left, greater than or equal to x plus 5 minus 2. So I'm looking for what are all the y's below that. And ultimately, right here is where the two radical equations, the two square root equations intersect at 4, 1. So at an x of 4, that's the first place where these things are equal. Well, where's the shaded area? Right here, if you look underneath the orange radical, but above the green radical, that's the place where they overlap. If I zoom out a really long way, it's all the numbers in that really narrow section where the orange and the green overlaps on Desmos. If I go and check and type in the original inequality, that shows everything to the right, but below orange and above green are all the solutions to this inequality. We need stuff that's above, again, the green equation, which is x plus root of x plus 5 minus 2, but below the orange equation, which is less than or equal to the root of x minus 3. So our final answer, like I was showing, is x is greater than or equal to 4 are what's going to cause solutions for both of the equations. Please take this and apply it to the work that we are doing here in Algebra 2.